Hello everyone. Are you going to build a chatbot? What will be the first option or what will you the first step you will take before going to create a chatbot? If I have to create anything, what will I do is to go to YouTube or google.com and search what other people have done yet. So after that I will start doing the same way. Let's type Python chatbot with machine learning or deep learning. Let's type machine learning this time and open the first link, second link, third link, and just open them. So see how they are doing these things. This guy is like what he is doing. He hasn't shown his code. Where is the code? I'm just looking for the code. Yeah. Let me tell you one thing. This guy is using 13 plus 6 around 20 plus 30 plus uh, 20 more 50 plus 20 more 70 around 70 lines of code to build a chatbot. Or it's a around a long huge it's a long code to just build a chatbot. And what other guy is doing? Almost all of these people are just using the same technique. He hasn't looked like he's using Chatterbot. Chatterbot is a conversational chatbot, and you can't use that Chatterbot for other purposes. Like you can't create a chatbot that is used to deal with medical data set, or you can create a medical you can't create a medical chatbot with chatterbot, or you can't create a finance based chatbot with chatterbot. It's just a greeting based chatbot. So what the other guy is doing, third guy, he's also using the chatterbot, and the fourth one is using chatterbot. So everyone is using chatterbot. Let's see what tech with him is doing. He's a great guy. I'm a big fan of him actually. He has a long coat, look like. Get started. Okay, everyone that is not using Chatterbot is using this dataset, and we are also going to use this dataset. So he reading the data set and putting the dataset in right data structures, and then cleaning the dataset and doing things like that. The first guy and this guy, tech with him, is doing almost the same things. Then is stemming the dataset and doing bag of extracting feature like bag of words features, and at the end what he is doing is like saving the model, and he's using a fully connected neural network for his chatbot. We are using machine learning because I believe that if we have less data, then we should opt to use machine learning instead of deep learning, because deep learning is data hungry and machine learning requires less data as compared to deep learning. So one thing I would like to show there is random choice. I would like also use the function, but I will tell you at the end that why. So let's go back to the dataset that we are using. Okay, this is okay. Here is the dataset that we are going to use. What we are going to use, and these people are doing that. They are getting features from the patterns and converted these patterns from string into numeric called encodings. So these encodings are like their features and the tags are their labels. So from the encodings of the patterns, they are going to classify which tag it is. It is greeting, goodbye, thanks, or no answer. Once they got the tag, the next step they will do is to figure out which response is connected with tag. So let's say the model classified the pattern as greetings, and in greeting we have three further sentences, and we will choose randomly like the other guys there which sentence can we can choose randomly. So here in what we are doing different is we are just building this all of this thing in less than 50 lines of code. These people are taking a lot of code, and we are doing just very less. amount of code for this thing. So let's start coding. The first thing we need to do is to import the file. We haven't the file yet. Let me figure out where is the file. I think TechWay Tim must have the file. I believe he has. Let me go to the part 1. I think we should have it there. Or otherwise, I will like to copy it from here and I will create a JSON object and I will like to uh, paste it there. Chatbot and what I will call it like intent.json. Open this object and paste this data set here. So now let's start coding. The first thing we need is a JSON library. Import JSON with open. Let's open this file. Its file name is intent.json. Intent.json as file data equal to json dot load file. Now our file has been loaded. If will be loaded if we run this command. Okay, here is the data file. It's like a dictionary with the key and the values. The dictionary further has dictionary in it with keys and values. Let's convert this data into pandas data frame for our ease of pre-processing. For that we need to import pandas. Import pandas as pd. def is equal to pd dot data frame and data. Okay, here if I just run this code, it will not give us the desired result. Let me show you that what we need. Here is the data frame and we can see that it's not like a data frame. It's actually still having dictionaries inside it. So what will I do is I will go one step inside and call the intents dictionary and all of its values are now put inside the data frame. So if I run this code again, I can see that here are the patterns, responses and tags. So now let's do some pre-processing. The first step we can do is like convert all of these into lower words. So lower words, df patterns patterns dot apply. What we are going to do that is we will take each of these lists and then from each of these lists we will lower each of these strings. So I'm called lambda x. What will lambda x do? It will take each of the list and from each of the list we have to now get each of the string. For getting each of the string from each of the list, we need to do list comprehension. I for I in x. When I write I for I in x, x this is x. This full line which is highlighted is x. And what is I is hi. Then I will become how are you. Then I will become is anyone there. Then hello. Then goodbye. So I will do I dot lower. It will convert all of this into lower. And when I will run that, you can see that here it is printed and I have to save it back to the data frame. So I will save it to back to the data frame. Oh, I will overwrite this and let me open it again. You can see that this has been converted into lower. So the next step is that we need to tokenize these sentences. Tokenize. So I will do this same thing again. df.pattern.apply. Let's copy this and paste this from here. if I do this thing, what will it do? It do nothing. So I have to tokenize this sentence. For that purpose, I will import NLTK from NLTK, which is a natural language processing library. NLTK dot tokenize import word tokenize. You can use split function and you can use word tokenize function. It's up to you. So let's again use the list comprehension and this time use the word tokenize I for I in X. What will it do? It will take each of the string and tokenize it. Now just run it and see what has been changed with our dataset. You can see that our dataset is now converted into list of lists. It has a big list in the beginning and small list inside of the large list. So now to access this list, we have to do double list comprehension, one for the outer list and one for the inner list. So next step we have to do is to lemmatize the dataset. You can skip this step for this dataset, but if you have some other dataset, this step might help you. Word lemmatization. Actually, it's up to you. You have to do stemming or you have to do lemmatization. You have to decide which step you have to take. You can try both or you can try without this. Let's import word lemmatizer from NLTK library from nltk.stem. Import word lemmatizer. There are different type of stemmer and lemmatizer. You can try which one works better for you. So let's copy this all from this thing and now as I have told you earlier that if I do I for I in X, it will just get the outer list, but we have to get the inner list. So I will have to do two time double list comprehension. Actually, I don't know whether we have to call it double list comprehension. What is the technical term for this? So if I do I for I in X, it will just give me the outer loop. So I will do it like this way. I for I in J, for J in what is J? J is actually the outer list and this is the outer list. Once the outer list is selected, hi will be the inner list. How are you? The will be the inner list, and this is I. Is any is actually I. So now we have to apply lemmatizer dot lemmatize on this. Um, okay, we missed one thing. We have to initiate the lematizer object of the OneNet classifier, OneNet lemmatizer class. Lemmatizer. Okay, then we can use lemmatizer dot lemmatize. Okay, now just run this. It will take a couple of seconds depending upon the size of your data set. Actually, I'm not sure that if there is any word that need to be lemmatized or if there isn't any word that need to be lemmatized. So you can check that if there is a word that need to be lemmatized, it will be lemmatized here. The next step we have to do is we can remove some of the uh, strings from here. We can remove stop words from here and we can do different things. Let if I have to remove strings from here, what I can do is or what I can do is I will remove all of the words that have length greater than one, sorry, that have length less than one or less than two. So let's do the copy this, uh, remove noisy word. Okay, now I have to do is like I for I in J. What if I run this code? You can't see any change in the uh, data frame because what it's doing is that it take the outer list and from outer list it will iterate each of the inner list and just put them back into the data frame. So if I add if length of I is greater than 2, only add those words which are greater than 2. So if it's an outer list is selected, then it will select the inner list, each element of inner list, and you can see that if an element such as is less than 2, it will be selected. Or I don't think it is selected because it is. I don't think it will be selected because it is not greater than equal to 2. So just run this and we can see that is not selected. So you can see that anyone is there but is has been removed. So it's there are different ways to handle this. You can remove stop words and you can do remove punctuations. The reason why I am not removing stop word is that I will remove it in later step while we were extracting the features. So let me explain this data frame. Okay, let me make it here. The tag is now our labels and the pattern is now our features actually. So what I want to do is that I want to make each of the I want to make each of the list in a new line so that how are you is tagged with greetings. Then anyone there in a second line and tag is greeting, and then hello third line greetings, good day fourth line greetings, bye fifth line goodbye, see you later sixth line goodbye. Okay, this way. I'm thinking not to remove the. I'm thinking right now to skip this line so that we want to keep all of these words. For that I have to rerun this. Later we can see that whether we have to remove the noisy word or we don't have to remove the noisy words. So just uh, create another data frame df1 and do df dot explode, and here we set patterns. You can see that previously the number of rows are 6, now the number of rows are 20. And we can see that greeting hi, greeting how are you, greeting is anyone there, and this is what we want to do. So the next thing is that we want this list converted back into string. Convert the list back to string. So df1 patterns, just copy this and type it again. Dot apply. This is my favorite function is just lambda x, and x is, as I have told you, now x is this full thing selected is x. This full thing selected is x. I will do join x. It will convert back it into string. Or instead of saving back it again, I will save it to x because this is our feature. So this is how these are our features. We have to vectorize it yet, and this is our labels df1 and tag. Sorry, tag. These are our labels and x is our features. Now we will use tf idea vectorizer to convert them into vectors. Vectorizer. This will convert our text back to vector into integers or floats from strings to numeric this way. We will use some scikit-learn dot feature extraction dot text import tf idea vectorizer. Vectorizer is equal to tf idf vectorizer. Just initiate it. Let me make it above a bit. And before that, I would like to split the data set into train and test. Split into actually I don't have to do this because data set is already very small. We have only 20 rows and we are just splitting it from sklearn dot model section. I believe it's in, yeah, it's in model section. Import train test split xtrain comma xtest. Actually, I don't know why people write x capital and y small, but I think it's a convention, and I'm also doing the same. Train test split x comma y test size equal to 0.2 is fine, I believe, because we have already a small number of data set, small size of data set. Xtrain xtrain is equal to, let's vectorizer dot fit transform x. I'm overwriting this, but you can rename xtrain vectorizer or something like that. X test equal to vectorizer dot, this time it will only be transform x test. Now just run this and we are good to go. The next thing we have to use a classifier. We can use naive based logistic regression. Let's use naive based classifier. You can use neural network or deep learning or whatever you want to use at this stage. From sklearn.naive base import Gaussian naive base. CLF is equal to Gaussian naive base and CLF dot fit transform. Rather I would to say CLF dot fit. It's not fit transform. It's just based x chain comma x test. Sorry, y test. What thing? Our naive base has been fitted to, but it will give an error because it will say that you have to convert the sparse matrix into dense matrix, and we can just simply do it like this way. Our naive base has been fit, and the next step we have to is calculate the score on the test data set x test comma y test and see what score it's give, and we again forget to convert it into dense, and it's give an accuracy of 0.5%. The reason is that we have already very small data set. Let's change the classifier and see how much accuracy we can achieve with another classifier, that is linear logistic regression. You can see that one more thing, I would like to shuffle the data set so that we can get a better. You can see that our accuracy is very low. One thing is that we can improve the data set, and the other thing is that we can use instead of one, right now the TF IDF vectorizer is used n-gram equal to 1. We can change this n-grams range equal to 1 comma 3 so that it can use 1 n-gram, 2 n-gram and 3 n-gram. So just run this again and we can see that there is no change in our accuracy. So one thing I can do is I can remove stopwords, so it might help us to get some better result, but look like it is not going to give us, yeah, it's one time gives 0.75. It's a better improve. Actually, why I'm running this again and again, because we have very less data set. It might happen that as we are not doing stratify equal to y, we should do stratify is equal to y, because there are chances that none of our uh, label from training class goes into the test class. There are chances that our test class has test data set of classes that haven't been trained. The test size equal to 4 should be greater equal to number of 6 equal to classes. We have to reduce it or we have to increase it. I think we have to increase it. Okay. Now we are 100% sure that all of the classes in training set are available in test set. As I am overwriting this data set, this gave me an error. This is a bit better than 0.25 and 0.2. And I have another data set that we can use is I can show you that data set. But before that data set, let's do something more and let's create a test function so that we can give each input and see the response of our text chatbot. So here is our text and which is a sample test that we will give it at runtime. The first step we have to do is to convert it to lower and then we have to tokenize it. So I have to use word tokenize to tokenize and then after converting it to lower. After converting it to lower, I have to again apply lemmatizer over it. Once I have tokenized the word, I know that it has been converted into list. So I have to use the list comprehension. I for I in text and lemmatizer dot lemmatize. This will lemmatize the text of our sentence, but it's now in a list. We have to convert it back to string. So I will use the join method to convert list into a string. Then once we have converted our list back into the string, we have to convert it into vectorizer text equal to vectorizer dot transform text, and once we convert the text into vector we have to predict it using our classifier clf dot predict text. Once we have predicted it, we can predict it from which class it belongs to. Let's run this code for a while and after that we will do the further work. Just type hi and see what it says. It says that I trable over raw text document expected string object receive. It says that it needs something from which it can iterate, like it need a list or it needs something like tuple or thing like that, and I converted it into a list and it will give another error, but I will show you once it gives. Okay, we are using logistic regression, so we don't need to convert it to two array. But if we are using Gaussian, then it will give us an error that you have to use the convert it into dense. Here we can see that. So again, switch back it to logistic regression. Here it is predicting correctly that this word hi belongs to greeting class. So we have to now generate the response. While true, take an input which is text using Python input method. Enter your question or press you to quit. If text is equal to Q so that we can quit it, break the while loop, else test pass this test taken from the input function to this test function. So just run this again. Okay, just write hi. It's a greetings and just enter Q and it will quit the loop. So now we have to generate the response. I will go to here in our function again and say that df response, which is this column, sorry, which is this column, but I have to select df tag, which is this column, is equal to predict. Okay, this is right now in a list and I want the first element of that list. So I can use this way. So if df tag is equal to predict, what will do, it will select which one we have to, it will make true which one we is matching. So the next thing is that we can use masking and print the responses here. Responses. Let's just print this one. It will print all of the responses related to this tag. Hi, you can see that it has printed all of the responses. But I have to do is random choice. I have to apply the random choice which I have told you earlier that we have to pick any of this response. Let me show you this file. If the user had said hi, you can say that hello, good to see you, hi there, thanks for visiting. You can print any of the response randomly. So print random. Let's import this random function for this purpose. Import random. Print random dot choice out. Um, just print this and see what we got it from here. Hopefully we wouldn't get an error. Okay, it is now printing this result in a list and all of the values are here because we are unable to select this column. So I will do out dot iLock. The random dot choice function is seeing this line as 1 and it has no other option. So if I use this way iLock dot 0, it can see that it has different one. Just try this one. Sorry, let's just finish this one and just run this again. Hi, it say hi there, how can I help you? Again, hi, how there I can help you, and for the third time it say good to see you again. And if I type bye, come back again soon. So this is our machine learning based chatbot which we have developed in around 30 minutes, and let me reduce spaces from there, and we can see that using how much line we have built this. You can see that it's around 56 line. If you remove the commenting line and the initial line, you can see that it's less than or equal to 50 line. So this is the end of this tutorial. Hope you like that. If you have any question, please let me know in the comment section. Thank you.